energy right now. I know it's the last panel. Yeah? Some energy here? Okay, good. Some energy in the room. Yeah, thanks again for hosting this. This is amazing. I think like this is one of the first panel actually around ECC that I see super specific. So I really appreciate the fact that we kind of like came up with this specific kind of topic, and also like, you know, it's super appreciated there is some people here hearing us. Okay, let's do it. Quick round of intro. Intro also like about, you know, what you're building around the space and why probably like it's so important to share this today.
I'll start. Hey folks. Itzhaki, I'm the CEO of Fhenix. We're building an FHE coprocessor. I think the word coprocessor probably has the worst meaning in that space. Maybe we compete with like smart contract, because when people think about coprocessor, automatically it's like some sort of a weird hardware thing. So think about it as encrypted computation as a service. So if you're building on any EVM chain, you can now introduce confidentiality to your smart contract very, very easily.
Awesome. Hi, this is Michael from Brevis. We built a smart verifiable computing platform. There are two products in our product suite. One is called a Pickle ZK VM that allows you to generate proof, ZK proof for any kind of computation you want. And on top of that, you know, we have kind of something called a ZK coprocessor, ZK data coprocessor that allows you to kind of generate a proof and run arbitrary computation on on-chain historical data, such as transactions, events, and states. You know, we work with some of the biggest DeFi protocols out there, like PancakeSwap, Uniswap, Euro, you know, Euler, across lending, spot DEXs, and you know, many other kind of perp DEXs as well. And you know, so far we have served more than 170K users to help them generate proof and enjoy a new generation of like intelligent DeFi features and you know, DApp experiences. You know, broadly speaking, what we do is that we help blockchain to scale by allow you to kind of offload the very complex computations from on-chain smart contract to an off-chain environment and generate ZK proof, where you can bring the proof back to the blockchain to easily verify and cheaply and easily verified. So as if like this kind of a whole computation happened on-chain. But there are many kind of other application use cases for Brevis that beyond just blockchain, such as in AI for verifiable inference, and in Web2 for you know, verifiable and privacy preserving identity solutions as well. You know, happy to talk more.
Hey guys, this is Deli from Automata. We're actually building the attestation layers for all sorts of like TE applications. Right now we work with a lot of rollups. We work with ZK system as well to provide things like multi-prover 2FA system so that TE can be used as a security hedge against some of the potential vulnerabilities in ZK systems. Also nowadays, there has been a lot of AI agent being built running in so-called confidential AI mode, which essentially is backed by NVIDIA's new series of GPU who have a TE capabilities. So what we're really doing is building contracts that running on like EVM chains, Solana as well, to verify the result and also the so-called attestations from these hardwares, so that users and developers can really know that they're dealing with the right party and also the right version of the code. So this is a very strong and also scalable performance solutions that can help us to achieve a more verifiable future, not only on AI, but on any sorts of computations. Also, there are a lot of attentions on using this for trading because TE is kind of an isolation solution as well. There has been a lot of interest on using TE for MEV solutions or for settlement before like even the transaction hitting the blockchain. So these are some partners. There are some partners that we're working with on this. We are also providing solutions to some other projects like WorkCoin user identities, because they are doing MPCs for as a surveys to really identify if each of the users is unique. What we're doing is simply just put MPC over TE so that you can easily prevent the collusion attacks. Also, maybe on FHE and on ZK as well, there are just a lot of overlapping collaborations right now.
Sweet. My name is Jacob. I'm the product lead for Boundless. I also still work at RISC-0. I think most people know RISC-0 for being the first RISC-V ZK VM, which was sort of this novel idea that I think is being replicated a lot in the space. Boundless is the evolution of RISC-0. we're really focused on bringing verifiable computation, not towards applications in Web3 that can use it today, like rollups, coprocessor, bridges, but really looking beyond to fix Web2 problems as well.
So this panel is all about kind of like prover systems, verification, and I just want to kind of like let's give some color here for everyone. You kind of like mentioned ZK, where even mentioning TE. Can you guys define a little bit like the different kind of like categories, right? And while researching, I was hearing more about FHE, ZK and TE and proof markets. But I would like that this explanation is done like, think about like, 5 years olds are hearing you guys, right? Not like super technical, because I'm still kind of like, confused a bit, right? When we're hearing debates, how is the approach? What are the trade-offs about each single kind of like, architectural design even?
Yeah, I can take this. I think this is a topic for like an hour presentation. We'll try to make this one pretty quick. Let's start with TEs. TEs are basically some sort of an environment within the hardware that you can run computation inside that environment, and everything that happens there is protected. It's protected by hardware, and you can actually do encrypted computation. They have a lot of benefits. They're fast. They also have some risks associated, and I'm sure that the team here would maybe disagree with me, but they're prone to side channel attacks, and at the end of the day, there is a trust assumption. You trust the hardware manufacturer. But I do see this as the rise of TEs. If you think about TEs, like 3 years ago, they were a big no-no here, and now many projects are using TEs, and rightfully so. Next, cryptography, we've talked about ZK, mostly as a scaling or a proving mechanism. Enables you to prove that something happened without actually sharing that how it happened. And lastly, FHE, which is the domain that we are at, fully homomorphic encryption. It's a very novel encryption technology that enables you to compute over encrypted data, which sounds a bit like magic, because if the data is encrypted, then how can you compute over that data? We were always taught, like in school, if you encrypt something, it's meaningless. But with FHE, you can actually do that. So you can compute over encrypted data. It's been available for many, many years, but was always considered as quite slow and very complex. There's been a lot of progression in that space, and it's really perfect for today. So I think it's not so much about one versus the others. Maybe FHE and TEs are kind of competing, but many of them are complementing one another in that regard.
Yeah, I just want to add a bit on the verifiable computing using ZK, right? And let me kind of walk you through a very simple example. So like in the simplest form of computing, let's say you have Alice and Bob. Alice is trying to compute 1 + 1, and Alice did the computation, get the result of 2. Now Alice is trying to convince, let's say, another guy, Bob, say, hey, like this 1 + 1 should be equal to 2. Like how would Bob do it? Well, in the simplest form of computing, the only way for Bob to verify the result is actually correct is to redo the computation itself. Like Bob actually need to re-execute a computation, spend the power to do it, and then get the same result and say, oh yeah, this is like actually 2. Right, so like verifiable computing is introducing a new kind of a paradigm here, where you have different roles in kind of a different people participating in a computation process. Now, Alice, instead of just getting the initial result, can also generate a ZK proof, which is like a magical thing, based on the input, which is 1 + 1, and the kind of computation you're running, which is like plus and addition, and then the output. So like then, Alice can send this proof, which is like a very succinct number, you can just think of this as a number, to any verifier that is just bystanding and looking at this. And a verifier such as Bob can just verify the result, verify this kind of a proof by running a very, very simple verification algorithm. And then, as long as this algorithm returns true, yes, this is like correct, and Bob can accept the result without re-executing the transaction. Now, why is this important? I used 1 + 1 as example, but like in fact, this thing applies to arbitrarily complex computation. Like you can even throw a large language model inference into the computation itself, and you can generate the proof of same size that only requires the same kind of a computation cost to verify. So that's kind of like the beauty of verifiable computing using ZK. That is, you effectively transformed some computation that you need to do, some recomputation that you need to do across a bunch of verifiers to, just a prover who can spend some additional computation to generate proof and just apply this proof to whoever wants to kind of verify the computation. Now, why is this important is because, in many cases, especially on blockchain, for example, executing a computation, the unit cost of executing computation is different from off-chain environment, right? So because blockchain fundamentally is replicated computing, the replicated storage, and therefore it's super expensive to run, let's say, 1+1. So now instead of running the computation itself, you migrate the computation from on-chain world to an off-chain world, and you just ask the Brevis, you just ask kind of a blockchain to verify the result of the computation in a very cheap, in a very cheap fashion, right? So that's how fundamentally why ZK-based verifiable computing can enable scaling benefit for blockchain and many other similar environments as well.
All right. I think I'd like to explain this from quite a different angle in terms of where the compute is running. I think mostly right now, if you're using some services or softwares, it's either running on your device, which is by default secure because you own the device, you own the data. Maybe you own some parts of the software or licensing, but this is more or less kind of a secure domain that you own. But if there's more computing that need to be done that can't be done on your local device, then you have to go to some sort of cloud services or today maybe blockchains for this. And this is where we need all sorts of these verifiable compute solutions as well, because blockchain is not scalable enough right now to fulfill all the need. So that's why we have ZK rollups for scaling. We have maybe TE and FHE for a little bit private computations. Of course, all this tech can be used together to create much safer systems. That's what we have seen in some of the ZK rollups. They're going towards this multi-prover adoptions. And not to mention that AI has really created huge demand in terms of the computing powers. It's essentially not possible to be done on your local device. We all have to use the centralized providers. That's for now, but maybe in the future, decentralized providers. But those are still kind of outsourced computations that are not running at your home or at your premises. In those cases, verifiable compute is super important. And the thing is, who's going to verify those computations for you? Traditionally, if it's locally, you have trust, nobody verifies. In a centralized manner, maybe the company is doing this, so you trust company, you don't have to verify as well. But when it comes into decentralized manners, some third party is running a service, is hosting a service, you'd love to have someone verifying for you. And in this case, blockchain could be kind of the players that are going to do all the verifications. So that's why we're bringing all the possible verifications on chain eventually. And this is kind of works across all the tech. Like ZK brings verifications on chain, TE brings that on chain as well, even FHE as well. So this is, I think there are common things out there and also different parts because each of the tech really have different trust assumptions. I would say TE stands out on both things. One is performance is good, but then people really bashing it because you have a lot of trust assumptions to make. You have to really know that the chip manufacturers won't screw up, right? They don't have any backdoors. They don't have any vulnerabilities. In order to achieve that, you can't really just trust them. You have to also push them as well to make sure that they're giving you something that you can verify. Therefore, now people are advocating for maybe more open source hardware so that you can even verify each part of the hardware is really by standard, right? I think these are the really different parts that differentiate TE from other things. But again, I think we're working at different layers. So potentially, if you're a developer, you could just really choose one of them or two of these tags, 2 or 3 of these tags to create your applications.
I'll sum it up. So we're all making trade-offs between security assumptions, speed, latency. I agree with Deli that it's really nice to use these technologies in conjunction with us. We're doing exciting work with Automata. I think ZK FHE is the most holy grail sort of cryptographic backend that changes the world. And we're all helping, right? You guys are doing great things. I'm super excited about the EF's push to do more open source standards for TEs. Brevis is doing great work about ZK, making it faster, and same with FHE for Phenix.
question, I mean, trade-offs wise, like, so how we kind of like maintain some kind of degree of decentralization and still kind of like, build scalable, proofs infrastructure?
I think right now, if you look at the scheme right now, I think sort of we are all getting support from operators who are naturally decentralized. But to the tech developers like us, what we need to do is make sure that it's really working across all type of infrastructures, no matter it's running on cloud or running on those bare metal operators. And I think it's because there's just like so many different types of hardwares. Like even in our domain in TE, you have to take care of like very different stacks from Intel's all the way to AMD or even like AWS on cloud as well. So I think like the key things we have to do is make two things easier. The first part is make the operator's life easier by automating things as much as possible, hiding all the details, make sure they can do like DevOps easily. The second thing is on the developer experience, because we don't really want them to face that there are so many different things to deal with. A better way is to provide a more unified SDKs, no matter if it's off-chain or on-chain, to really help them to create applications, to help them to run some compute at a particular maybe operators or many operators, and eventually get the result verified on-chain and consume them on-chain.
Plus one to that, I think the nice thing about TEs and ZK is that your trust assumption changes a lot. It's just one of n. Traditionally when we think about like distributed systems, that trust assumption now needs to be like 2/3, or really bad things starting to happen, like liveness and safety. The way we approach this at Boundless is that anyone can participate in the infrastructure. The infrastructure to run ZK, it's all public knowledge. If you want to go be a prover on the network, it just became permissionless like 2 weeks ago. Takes 30 minutes and a credit card to set up. There's like 300 people generating proofs. I have no idea who they are. I haven't talked to them. So keeping these backends like open and permissionless, I think we get into dangerous territory once we have parties closed sourcing implementations, closed sourcing the necessary orchestration software that's needed to run these systems.
Question, you touched a bit on developer experience, and I really like what you're saying about a kind of extracting the way how developers are actually like building, for example, dApps with specific kind of like proofs there. What's your take around kind of like, toolings right now? Is there kind of like some specific vertical that is kind of like lacking? What are we missing right now in order to kind of like maybe optimize a developer experience? I was in Berlin, check it out, also the Fhenix SDK. I mean, it's quite smooth, right? But I also like wondering like if you guys see what are we missing right now in terms of kind of like tooling for devs?
Yeah, I mean, ZK used to be quite horrible in terms of developer experience, because like you basically need to understand the underlying mathematics of this, and then write different kind of constraint programs to say, okay, like this thing does this, and even just like writing really an addition or sorting algorithm is like 250 lines of code, in ZK proof-based domain-specific languages. But like, what Brevis really enables is that, it really give you a very kind of developer-friendly platform to implement any kind of computation and verify it in ZK, because we have Pickle VM as a general RISC-V, instruction set supported VM. That means that you can just write plain Rust and to express whatever business logic you want and get that verified and generate proof on that kind of a program. But this kind of additional like developer friendliness brought by ZK general purpose ZK VM also comes with a trade-off. The trade-off is obviously on the performance side. Like if you have a very, very general system, you generally have like pretty relatively poor performance comparing to a very specialized optimized circuit itself. So what's really unique about the Brevis and the Pickle is that we try to achieve the best of the two worlds. That is, we build Pickle as an extremely modular ZK VM, where the kind of general ZK VM itself is just acting as a glue. And it'll glue together multiple different application coprocessors. In this case, like we glue together ZK-ML coprocessor that can handle machine learning inference workload. We glue together data access coprocessor, allow you to generate proof of on-chain historical data. So these kind of a high-performance system are just not just a simple, precompiles or things like this. This is actually a full-fledged system that allows you to offload a huge chunk of your application's business logic to this kind of a specialized system, and then bring the result back to your ZK VM and let the ZK VM consume and run more complicated application computation on top. So this kind of a combined approach by combining a general glue versus a bunch of a specialized application coprocessor is something that we feel that why we're getting a lot more adoptions in the verifiable computing space as well.
Yeah, and we can all probably acknowledge that there is a constant battle about developer attention, right? Developers appreciates privacy and appreciates verifiability as long as it's very, very smooth. If we start making things quite complex for them, they'll just go and move into something else. So I think all of us are trying to figure out what is the best mechanism to help developers and onboard them and give them the tool, because I think like most agree that if it's very easy and native, then there is a significant benefit. But if you start adding complexity and limitation and performance, then it's probably, we're not in the right space. The way we tackle it is, of course, we provide the same developers tool that the developers are using and speed up performance. But I think we all also acknowledge that this is kind of a unique point in time with the increased adoption of tools that enables like AI-based tools. You now see developers really changing how they used to work in the past and really creating like 80% of the code in like 30 minutes, and then working on modifying to fit basically to what you're going. So I think like for all of us, the world is going to look quite different, I would say, in the next 6 months. But it is very, very important and imperative that, at least from our perspective as a company that provides confidential compute as a service, that it's very, very fast, and we are working on all layers, product-wise, research-wise, to actually make sure that FHE at some point would be considered as fast as TE is in that regards. So make the computation quick, make sure that the tools are supportive, and help onboard developers as quickly as possible.
Go for it. Yeah, we take a little bit different approach at Boundless, right? To reinstate our vision, like we're trying to bring ZK to around the world. We really view ZK, it will be as big as like key pair cryptography in the world. It really is that big of a fundamental shift for just the way security in the internet works. And we are working on 2 active areas. One is, with the RISC-V ZK VM, what did the TAM of ZK development go to? It went from a PhD cryptography to anyone that knows Rust. That's still quite small. I think Go has 20 times the amount of Rust developers, so we're still fighting over quite a pie. We now have the ability to support any language in the RISC-V ZK VM and can add this to other ZK VMs as well. So we want to add Go, we want to add WASM-based languages, we want to add Python, all these to really expand, right? If I'm going to go to Amazon or Facebook and ask them to use ZK, and then I all of a sudden have to ask them to Rust, but it's like a website team, they're not using ZK. And the second thing is continue to abstract, right? So with Boundless, we want to abstract the infrastructure, we abstract the ZK tech, but continue to go. We really want to come up to, companies like an Amazon that's really, interested in stablecoins and just give them a solution out of the box that saves them money.
I'm hearing more and more kind of user specific kind of use case, right? So what people are building. I just want to understand a little bit, and this is a yes or no kind of answer. Do you feel like eventually we will kind of converge more in a unified, trustless kind of layer, or no?
No.
You don't feel like we will have more fragmentation?
I don't think there will be fragmentation. We have a pretty exciting, announcement going out next Tuesday that everyone should check out. How we think we can fix fragmentation, within the Ethereum ecosystem with ZK. I do think that running your own L2 is a great business. There's a reason why Coinbase and Robinhood have chosen to do so. There's a lot of value accrual at that level, and we'll continue to see people, sort of launch that type of environment where they get to control the flow of assets, or the flow of access to assets, and capture sort of priority fees on top of it.
Yeah, it's probably good for the company deploying and building the stack, right? But it's not good for a user.
I really think you can get to a place where the user we have a blog post going out on Tuesday, how like lines between chains start to blur, and you can really start to access state across chains, and ZK helps do that. It will really like start looking like one big environment instead of, the current, I need to move, like $10 million from Arbitrum to Unichain to take care of the incentivization. Let me withdraw for 10 days or pay like a bridge like 10K at that size. You'll really be able to just look at things.
Yeah, although I think like this discussion is all about chain abstraction, right? Like, but that's probably another kind of like panel. So give us some kind of like hot takes. I think everybody's hot here. So I'm like super sweating. We are almost like at time here. What are your kind of like spicy hot takes around the space right now that you think they should be debated more that maybe we're not even speaking in panels?
I think the good thing is that we're starting to see the EF doing more in that space. They're becoming a bit more vocal about the value of verifiability, the value of privacy. They've been talking about ZK for quite some time, but you see an increased adoption on the EF side, both in FHE and TEs. That's a good sign. I think there are a lot of problems with the way the EF operates today and still needs to fix them before we can really reach to this phase that you just described before. I will say that specifically for me, the domain of stablecoin and specifically confidential stablecoin is one domain that really excites me. I think with the increased adoption of institutionals that are coming here, we heard it from the team at Arbitrum like a few minutes ago, that will become a very appealing opportunity for them.
Okay, hot takes. I think ZK, as a whole domain, really kind of suffered from the initial kind of adoption vertical, which is like ZK rollup. ZK rollup, as they are now, doesn't really have a good product market fit, and we should really kind of not focusing on trying to convert some like other optimistic rollup into ZK rollup because like they don't want to. And what we feel is that there are actually a lot more use cases in generalized ZK verifiable computing than just building rollups. And like things like from very simple things, like if you can dynamically change users' trading fee on your DEXs based on their historical trading volume, which is like available in every centralized exchanges. But now this kind of a thing become possible on PancakeSwap with like our integrated launch, and it will be soon be available in many other DEXs that are launching very soon with Brevis powered hooks and dynamic fee-based plugins. So these kind of user experience improvement features are only possible through the integration of like things like Brevis. And these are the things that we should really kind of focus and spend more energy on. And we do see there's a kind of generally a new generation of verifiable applications where you can even build a hyper-liquid equivalent where you have the extremely kind of a fast and smooth user experience, but at the same time have a privacy-preserving property, with all the user orders and open interest that is like private, in your entire kind of a perp DEX while maintaining the trust-freeness of withdrawing any time, right? So these kind of things are possible with ZK, and we're just scratching the surface right now.
Yeah, I actually have two hot takes. One is regarding TE, the other one is regarding privacy, which works for all of us. I think on TE, there may be a future that in the future, like everything gonna running on TE, like because now it's kind of going that directions because all the chip manufacturers, Intel, AMD, they are making the cloud-based chips, essentially kind of have this TE running. And cloud providers may just choose to run all the VM instances in a TE because there's nothing to lose, and it's strictly better to have it running there because you have much stronger isolations, much stronger security guarantees, and therefore in the end maybe developers don't really need to understand because it's already by default protected. Second take is on the privacy. I think it's really good to see that at least EF is resuming on privacy again. I think in today's Vitalik's talk, he mentioned about privacy on all sorts of fronts, like things on like privacy on reads, privacy on write, privacy on like payment as well. I think this is definitely something has been lacking, and maybe now we really are back to the fundamentals, just like the topic of the event, we can really focus on like having privacy as good to have and must to have properties alongside with the main like product feature that you are building, and we should really have it by default.
Which one do I want to choose? Quick question. I'm just generally curious. How many people knew that there's like a TE already on your iPhone? There's a TE like on an iPhone today. Do people know that? A few people? Yeah, fun fact. 25 ZKVMs isn't enough. Right? Like, I mean, like seriously, 25 ZKVMs only proving EVM blocks is way too many. But to the point, like back to my point earlier, we've used ZK as important as key pair cryptography. And as we go to broader use cases, we're gonna see so much more experimentation and optimization around those use cases. Yeah.
Any question, guys? I think we have one or two questions here. Okay, 3, 2, 1, and there we go. Big round of applause for everyone here.